So let's start the new chapter, which is treatment of water in environment engineering. So the first question which came in GATE 2020 set 1 is, this is of 1 mark. So the first question is, during the chlorination process, aqueous chlorine reacts rapid with water to form Cl, HOCl and H plus as shown below. This is the reaction. The most active disinfectant in chlorination process from amongst the following is, we have to tell which one is the most important active disinfectant. So first of all, getting into the question, we should know the concept, which is disinfection. So what is disinfection? It is defined as the method of inactivation of harmful microorganisms in water, either by the physical or chemical process. Okay, so disinfection is nothing but we are going to inactivate the harmful microorganisms that can create harmful diseases if we consume that water. If it is treated, if it is not disinfected, the water is not suitable for us to drink. So disinfection is the most important process to do before supplying it to the domestic use. Now chlorination is the process. Here the word is chlorination. So chlorination is also, it is a process that is done for disinfection, and it is major method of disinfection. In India, we use majorly chlorination for disinfection. There are various reasons. It is cheap, it is good disinfectant, it is having higher residual power. That means it will be in remaining stage even after disinfection is completely done, and the effect of this disinfection will be for some time till the water is supplied to the domestic use. Now, when chlorine is added to water, the reaction takes place between them. That reaction is written here. When chlorine is added to water, there is a reaction that takes place, and that reaction is something like this. Okay, now at pH less than 6, when water is having pH less than 5, chlorine does not react with water and remains as free chlorine. At pH less than 5 of water, chlorine will not react with water and it remains as free chlorine. Or we can say unreacted chlorine. Reaction of chlorine with water is something like this. Out of all these forms of chlorine, like HOCl, Cl, HOCl minus, the all forms of chlorine, this HOCl minus is the most destructive. It is the most destructive. It is 80% more effective than OCl minus ion. It is 80% more effective than OCl minus ion. Hence pH is mentioned just below 7 for most effective chlorination. So we can say the HOCl is the most effective disinfectant in chlorination process. Let's do the question number 2. Two identically sized primary settling tank receive water for type 1 settling surface overflow rate SOR maintained in the two tanks at are 30 meter cube per second per day and 15 meter cube per meter square per day. It should be meter square per day. The lowest diameters of the particles which shall be settled out completely under SORs 30 meter cube per meter square per day and 15 meter cube per meter square per day are designated as D30 and D50. Ratio of D30 D15 round off to 2 decimal places is. So now they are talking about the main thing, that is surface overflow rate. So we should first of all know what is surface overflow rate now. Surface overflow rate, in short form we say SOR. So surface overflow rate is defined as the volume of water flow per unit time per unit surface. Area. So the surface overflow rate is nothing but the volume of water flow per unit time per unit surface area. We can say that surface overflow rate is nothing but the settling velocity of the particle. If a particle is going from this tank, let's suppose, and water is till here. Now if there is any particle which wants to settle, okay, so the settling velocity of the particle, which is how much speed of the particle will take to settle before going out of the tank, right? So it should be settled before going out of the tank. So it can also be thought of as the settling velocity of that particle, which if introduced at the topmost point of the inlet will reach the bottommost point of the outlet of the tank. So it is also defined as that velocity. Now this surface overflow rate is also given by Q, total discharge, upon B into L, where BL is what? Plan area. If we see from the top, the area which we see is plan area, which is B and L. This is L and this is B. So B into L is nothing but plan area, right? So this is the surface overflow rate. And settling velocity, if we want to know what is settling velocity, so settling velocity is also given by the Stokes law. Stokes law gives us the settling velocity, which is nothing but V is equal to, we can say Vs is equal to rho G gamma S minus gamma W upon 18 mu into D square. This is the Stokes law. Okay. Now for the calculation purpose, in the question we have given that first settling velocity, the settling surface overflow rate or settling velocity is 30 and 15 meter cube per meter square per day. So the settling velocities are Vs1, let's say, that is 30, and Vs2, let's say, that is 15. So Vs1 upon Vs2, and they want us to know what is the ratio of diameter. So from the settling velocity we can see that the ratio of settling velocity will be, if all other parameters are same, it will be proportional to the square of diameter. So it will be like this, and that is equal to 30 upon 15 d30 upon d15 whole square, we can say, and d30 upon d15 is nothing but under root 2, and that is 1.414. So the answer will be, the ratio they are asking of d30 by d15, it is 1.414.